Hey everyone, so in this video I'm going to go over dividing radicals. So let's start with the do now. It says you are a business, you own a business that repairs computers. The average income can be modeled by this polynomial, C of x. If for 1 year the number of computers repaired was modeled by R of x, write the polynomial that can be used to model your income for the year. So we have your average income with this function, and the number of computers that you repair with this function. So in order to find your income for the whole entire year, you would multiply your average income, which is your cost per computer, by your revenue. So I'm just going to multiply these two to end up getting a polynomial that will combine. So I'm going to do this times this, and I will use box method. I'm going to try to actually zoom in on this so we don't have this all squished up. Okay, so I'll do 8x squared plus 6x plus 7, and then 50x and 120. Boom, boom, boom. All right, so I'm going to do 8 times 50, which is 400, and then x cubed. 50 times 6 is 300, and then x squared, 350x. 8 times 120, that's 960, x squared. And then to 120 times 6, that's 720x. And then 120 times 7 is 840. Okay, so I'm going to write a polynomial that represents my income for the year. So I'll just say income of x equals, there's no other to the third, so I'll keep that. But there are squareds. These guys would combine to 1,260x squared. 720x and 350x, that'll combine to 1070x. And then 840. There you go. Okay, now let's get into dividing radicals. So to divide a radical, what you need to do is make sure you check out for the index. We're going to check the index, make sure that they're the same index. Then you're going to divide the radicands, which is the inside of the radicals, and then simplify. So for this example here, I can notice that they're both square roots, so I can go ahead and divide the numbers on the inside, and then I would simplify. The highest perfect square inside of 12 is 3. Is 4. Product of this is 4 times 3, which gets you 12, and we're going to pick this because the square root of 4 is perfect, comes out of the house, and then the 3 stays inside the house because it's not perfect. This one here, you cannot divide 5 by 9, but what you can do is you can split this up, and you'll get square root of 5 over 3. Okay, this one here. So think of it as two separate problems in a way. 6 divided by 4. If you guys remember, you can go to your if you go to the regular window on your calculator and you press alpha, y equals, it'll get you n over d. You guys do alpha y equals, you'll see n over d. It'll give you, type in 6 over 4, and it will reduce it to 3 over 2. Okay. So then what you're going to do is you're going to do 40 divided by 5, and you'll get 8. And then you'll break up that into 4 and 2, and the square root of 4 is 2, rad 2. Put this over 1, these will cancel, you'll end up getting 3 square root of 2. Okay, where are we up to? Now, if you notice here, we got a binomial and a monomial. So if you remember back in Algebra 1, what you can do is separate it. I call it share the love because you're sharing, you make a heart, and you share the denominator with both of them. So you share the denominator. And then you reduce. So 12 divided by 6 gets you 2. 45 divided by 5 is 9. Minus 6 divided by 6 cancels to 1. And 20 divided by 5 is 4. Then 2 times 3, because the square root of 9 is 3. And then minus 2. And then we're going to end up getting 6 minus 2, which is 4. Okay, so same thing for the next one. Wherever it is, there it is. You're going to share the love here, share the denominator, so it'll be 8 square root of 32 divided by 4 square root of 2 plus 12 square root of 18 divided by 4 square root of 2. Okay, so 8 divided by 4 is 2. 32 divided by 2 is 16, plus 12 divided by 4 is 3, and then 18 divided by 2 is 9. Okay, then you're going to reduce. So it'll get you 2 times 4 plus 3 times 3, 8 plus 9, that gets you 17. Okay. Now, the next section, we're going to just skip. It's an honors topic, and you don't need to know it for this class. So the next page, you can just skip. But what we're going to do are 3 extra problems that I wanted to go over because they're a little bit more challenging, and you do need to know how to attack something like that. The goal really was that we had this would have had this in the printouts this year, but because of everything that happened with COVID, I wasn't able to get my printouts done and fix them. So I'm going to do 3 questions next that will help you do more advanced division problems. So like I said, this page we're not going to do. I could do letter H though. This is not an issue. We just did one just like this. Share the love. So you do 15 cube root of 40 over 5 cube root of 5 minus 5 cube root of 5 over another 5 cube root of 5. This would all just cancel out to 1 right there because it's the same thing, same thing. Then 15 divided by 5 is 3, and 40 divided by 5 is 8. The cube root of 8 is 2. 6 minus 1 is 5. So hopefully that's an answer choice. Yep, okay. So these are 3 examples that I wanted to go over. They're a little bit more challenging. And the reason why I wanted to go over them is because they're a little bit more challenging and you will see questions like this. So first off, what you can do here is realize that these are the same type of root. They're a cube root. So just divide the inside. Remember, when you divide, you subtract exponents. So it'll be x to the 6th. And then you can reduce this to be 6 power of a root. So remember, it's power divided by index. That would just get you x squared. Okay, so that's one of them. And then here's this one. Now notice here, there's a 3 in front of here, but this is a cube root. See where the 3 is on there, and see where the 3 is here? The 3 is in front. So you're not going to forget about that 3. That's on the top, okay? And then you're going to divide. So I'm going to write it like this because this one's a little weird. When you do this one, let me just clean this up. The 3 is just going to chill on the outside. You're going to do 2 over 18. 2 over 18 reduces to 1/9. Then you're going to have x over x to the 5th. Think of it this way. There is 1x on top and 1, 2, 3, 4, 5 x's on bottom. That would cancel out one of these and be left with x to the 4th on the bottom. Same thing with the z's. There are 1, 2, 3, 4, 5 z's on top and 1 z on bottom. When you subtract that, you end up getting 4 z's on top. And then you can reduce this. The 3 will just stay. The square root of z to the 4th is z squared. The square root of 9 is 3, and the square root of x to the 4th is x squared. These would cancel out. You'd end up just getting z squared over x squared. And then there was one more I wanted to go over, if I can find it on here. Yep, all right. Now, notice with this one, you cannot divide on the inside. You can't just divide these because these are different indexes. This is a cube root, this is a 4th root. So we're going to have to simplify them one at a time, and then reduce dividing. So 9 divided by 3, that works, that's x cubed. 12 divided by 3, that works, that's y to the 4th. Remember, I'm just doing power over index. 8 divided by 4, that's x squared. And then 12 divided by 4, that's y cubed. Now, since they're out of the roots, I can just simplify normally. So like I would do normal exponent rules. 3 minus 2 is x to the 1st, and 4 minus 3 is just y. And those are the more challenging ones. So I hope this helped you with your division of radicals. As always, if you have any extra questions, come do extra help. And I'll see you guys soon.